In order to tell whether an equation represents exponential growth or decay, there's just one number we need to look at, and that's our base, the number with the exponent on it. So in our first example, that's 0.05. In our second example, that's 1.98. So that's the one and only number you want to look at for growth or decay. Now, if that number is a number less than 1, it's going to be a graph that represents decay. That number won't be negative, so we can say that the base is between 0 and 1. It's less than 1, but bigger than 0. If that base value is bigger than 1, we'd say it represents growth. The next thing I want to take a look at is what each of the other numbers represent in this model. And so both examples start with this 3.5. That number in front, we had called the A value in class. That number always represents our initial amount of something, so how much we start with. The next number that both have in common are the exponent, the 10 in this case, or obviously the 10 over here. That number, our exponent, always represents time, whether that's 10 years or 10 seconds or 10 minutes, I don't know, but we'd find that out when we were working on a specific problem, but that's going to represent our time unit. The very last thing I want to find then is the rate that we're either increasing or decreasing by. Well, we have to be really careful with this because the R is not that number in parentheses. Instead, if you remember from our model, for a decay model like this first example, what's in that parentheses is 1 minus the rate. So really I have a little algebra equation I want to solve. I want to know 1 minus what rate would get me the number I have in the parentheses. So it's not 0.05, it's what I would subtract to get 0.05. Well, if you don't like working with decimals, you can change these into percentages. So 1 would represent 100%, minus what rate would get 5%. Well, looking at it that way, I can see that, okay, well, my rate decrease must be 95%. So it's not the number in parentheses, it's the number we get, the number that we took away from 1 to get that. So in this case, 95% or 0.95 would represent my percent decrease. In the growth model, it's a little bit easier to find. Once again, be careful, it's not just the number that's in there. Remember, in our growth model, we had in parentheses 1 plus the rates would equal the number I get there. So again, that's the little simple algebra equation I want to solve. If it's easier to work with percentages, then let's change that to 100% plus what rate would equal 198%. Well, looking at that, I see that I've got an 89% increase in this example.